morning or good afternoon, depending upon where you happen to be joining us from, and welcome to today's webinar. I am George Laranger from Array Technologies, and I'll be guiding you through our discussion with experts from Array Technologies and VDE Americas on defending your solar assets, lessons in extreme weather preparedness and mitigation. Presenting today's content will be Kathy Hansen, Senior Director of Product Management at Array, followed by Sumanth Lokanath, Senior Manager of LCOE from Array. We will then introduce two of our colleagues from VDE Americas, John Previtali, VP and Senior Principal Engineer, and Dennis Weaver, Staff Meteorologist, who will detail some of the analysis that they have done on recent severe hail events. The course of today's presentation will cover several key focus areas. As many of you are aware, the frequency and severity of extreme weather events have been on the rise globally. This trend poses significant risks to various infrastructures, including our solar assets. Notably, hailstorms have become a growing concern for utility-scale solar sites, with incidents like the 2024 hailstorms in Fort Bend County, Texas, causing substantial damage to solar installations. Now, in response to these challenges, our webinar today will explore how optimized stow protocols and cutting-edge solar tracking technologies can play a pivotal role in mitigating hail-related risks by effectively reducing potential impact of hailstorms and preserving asset integrity. We will delve into a forensic analysis conducted by VDE Americas, focusing on the historic hailstorms that struck Fort Bend County in 2024. This analysis provides invaluable insights into the impact of such events on solar projects and underscores the necessity for proactive protective measures. We'll showcase how Array DuraTrack demonstrated resilience during two consecutive 500-year hailstorms. This exemplifies how advanced tracking systems can prevent significant asset loss and maintain operational efficiency under extreme conditions. Finally, our session will shed light on how Array's differentiated technology not only safeguards against severe weather, but also enhances energy yield. By intelligently adapting to varying weather conditions, Array Technologies can optimize performance without compromising on protection. Again, thank you for joining us today. We look forward to an engaging and informative session that equips you with the knowledge to protect and enhance your solar investments in the face of evolving climate challenges. With that, I'd like to turn it over to Kathy Hansen from Array to begin our presentation.
Thank you, George. I'll start off with a little bit of an introduction to Array for the people who aren't familiar with the company. Array has been around for more than 30 years in the solar tracker industry. We have over 1,000 employees. We're approaching $1 billion in revenue for this year, and we have over 300 patents issued around tracker technology. Array has a robust and diverse global supply chain. We've eliminated single sourcing for all of our components that are related to the trackers. We have a global supply chain that can be tailored to fit individual geographical needs. And that includes having high domestic content to meet local requirements in the US, Australia, Brazil, EU, South Africa, and the Middle East. Array's product portfolio consists of a variety of different trackers. Excuse me. We have both AC powered trackers as well as DC powered trackers, which is unique in the industry. Our gold standard tracker is the very well-known and well-established DuraTrack product. Connected to DuraTrack also, and built on the DuraTrack foundation, is OmniTrack, which adds additional terrain adaptability and flexibility. Moving to our DC-powered solutions, we have Skylink, which was recently launched into the commercial market. Skylink provides a wireless, all-weather, string-powered DC control system, as well as it's based on the DuraTrack structure. And then finally, for outside of the US, our primary target is with the H250. That is the STI legacy tracker solution, and it's particularly useful for for sites that are irregular, have high angles, or are fragmented. So with that quick introduction to Array, I'm very pleased to introduce Mr. John Privatali, who is the Vice President and Senior Principal Engineer with VDE. Go ahead,
Great.
John.
Thank you so much, Kathy. Excellent. So I'm going to talk about a forensic analysis that ATI, Array Technologies, asked us to do to take a look at the effect of some major hailstorms that impacted an area of Texas called Fort Bend County. And Fort Bend County is where the Fighting Jays project is that was actually decimated by these hailstorms that I'm going to talk about in March of last year. But before I begin, I'm going to just tell you who VDE Americas is briefly. We are a technical advisory firm owned by VDE, the company in Germany that was started about 160 years ago by Werner von Siemens, who is essentially the Thomas Edison or Nikola Tesla of Europe. And in Europe, we work very much like UL or Underwriter's Laboratory, testing electronics goods. But in the United States, we have a team of engineers and meteorologists and applied scientists who are totally focused on preserving the performance and verifying the performance of solar power projects and with energy storage. And we've supported about $15 billion in financing of operating solar power projects and energy storage projects over the last 10 years. And through that work, we have become really, no doubt, the leading expert in hail risk assessment and mitigation services for the solar power industry. So the severe event analysis for Fort Bend County involved looking at multiple projects around the project just south of Houston. And as you'll see on this map, Fighting Jays, which is designated as a star, really took a direct hit from the hail that is presented in this map. But there were other projects around Fighting Jays that were also affected by this weather system and these hailstorms. And so specifically, we went around and we talked to the operators of these projects, and we also looked at the radar that was available to see which projects were directly impacted by storms. And we found that 3 projects around Fighting Jays were directly impacted: Cutlass 1, Cutlass 2, which are 2 adjacent projects, and Old 300. And before I let you know what happened in detail with regard to the arrays, I'm going to hand it over to my colleague, Dennis Weaver, who is our meteorologist, to talk a little bit more about those hailstorms that happened in Fort Bend County. Dennis, take it away.
Thanks, John. Yeah, so like John mentioned, we're really focused on this Fort Bend County region of Texas and a few severe weather events that occurred last March on the 15th, and then also in the early hours of the 16th, looking at both the Fighting Jays project and also a few of the projects in the vicinity, the Cutlass 1 and 2 and Old 300 projects. So there was actually a severe thunderstorm that came through earlier in the afternoon on March 15th, about 3 o'clock local time, that passed just to the north of Fort Bend County and the projects that are outlined in the image on the slide. That storm didn't really have an impact on this particular area, and we're not going to dive into that. But there was another storm that occurred on the 15th from right around 5 to 6:30 local time. And that's what we're looking at in this particular image. So This is what we call the maximum estimated size of hail, or mesh. It's a radar-derived product. So the way I like to think about it is, I think we're all familiar with our, reflectivity values, radar reflectivity that shows up when you look at radar on your phone, or if you're watching a weather broadcast. Basically, what this represents is a conversion of those values into a hail size estimate based on where we know within a cloud that hail is likely to grow. There's a couple caveats with using this particular product, one of which is that we know that especially at large hail sizes, it tends to overestimate a bit. And I'm going to talk a little bit more about that later. The other is that there's a slight spatial uncertainty. And the reason for that is we're scanning through a cloud and we're making an estimate of hail size at the cloud level. Well, as the hail falls towards the ground, it's being impacted and affected by the wind field that it's falling through, et cetera. So I'll touch a little bit on that with each of these events as well. But that's sort of the general basis for using this mesh analysis. And what it does a really great job of is giving us a spatial understanding of where that primary swath was, and then also relative hail size within that swath and across that swath. So here's a time lapse of the storm that occurred on March 15th, and it doesn't appear as though it's moving. But what I can tell you is that essentially, yeah, go back here a second. Here we go. This particular storm is what we call a high precipitation supercell. And so what that means is, namely exactly what it sounds like. It's producing a large amount of precipitation, a large volume of precipitation, and also a large volume of hail. And in these particular systems, what we typically see is that the strongest wind at the surface sort of comes from right behind the hail, the primary hail swath. And so in this case, sort of out of the slight northwest direction off towards the southeast direction. And one thing that could possibly do is actually shift this primary swath and these higher hail values slightly off to the south and the east, if anything. I mean, we're talking maybe the order of a kilometer or two. And the exact value is not known, and it's going to be storm dependent. But just so we have some background on that. We can also break this down more statistically and look at spatial area by project that was potentially impacted by different hail bucket sizes. So we can notably see that here on the 15th, it was actually the Cutlass 2 project that likely was impacted by the largest hail from the system, sort of in that 50 to 75 millimeter range. Even if you sort of take in a little bit of spatial dislocation and say that might have been just to the south and east, that kind of just puts that into the Cutlass 1 project. So certainly between the Cutlass 1 and 2 projects in this particular event, experienced sort of the bulk of the larger hail that was produced. We had another storm that came through in the early hours of March 16th. And it's a rare storm to get overnight, and I'll talk a little bit more about that as well. But from 2:30 to 3:30 in the morning local time, and you can see just looking at the spatial mesh map here, Fighting Jays took a direct hit. Those estimated values of greater than 100 millimeters, like I said, that's quite likely an overestimate. In this general area, we had observations at the ground of about 2.75 inches in this vicinity. So that's in the 60 to 70 millimeter range, and it does correlate with what we would typically expect that overestimation to be at those large hail sizes. So keep that in mind, but we can take a look at the time series for this event as well. Once again, we're dealing with a high precipitation supercell. So in all likelihood, the winds are sort of coming in that very similar direction out of the northwest slightly and pushing off towards the southeast. I'm also just going to note here that a couple minutes into this time series, right around 7:50 UTC, so 2:50 in the morning local time, is when we got our first National Weather Service warning for the storm. So the National Weather Service warnings typically indicate or always indicate the potential for 1 inch hail or greater. That's the definition that's baked into the severe thunderstorm warning itself. With the next radar scan, about 5 minutes later, they upgraded that warning to what's known as a severe hail tag. And so that particular issuance indicates the potential for 2-inch or greater hail, which in this case we did end up seeing in the Fort Bend County area via observations and obviously from this radar analysis as well. We can also break this down by hail bucket size and project area. So once again, in this particular storm, Fighting Jays likely took a larger portion of the hit at the large hail sizes, you know, considering everything sort of above 50 millimeters, but also the old 300 project experienced, I mean, several square kilometers that were likely above 50 millimeters based on that radar analysis, you know, the 50 to 75 and the 75 to 100. You can also take a look at just kind of zooming out and looking at both of these storms in comparison to one another. I mean, they did occur, you know, within a 12-hour time frame of one another, and I'll talk a little bit about that. But the interesting thing from this particular chart is the observed wind speeds that we had in each of these events. So for the event that occurred earlier in the afternoon on the 15th, max wind speeds that were observed by ground stations was about 51 miles an hour. If we take a look at the observed wind speed at Old 300 during the storm on the 16th, it was about 20 miles an hour lower. And this really just goes to show, you know, I think it's easy to think, you know, higher hail sizes or more intense hail sizes is automatically going to be stronger winds. There may be some truth to that, but it depends quite a bit on storm relative position. So where are you in relation to those storm dynamics? And in some cases, you can get lower wind speeds and still see significant hailfall. The wind is a highly variable variable when we're talking about the meteorological analysis of these severe thunderstorms. And also look at this in terms of our predicted probability. So this chart here is specifically looking at our expected return interval for different size hail events. And what we typically say is that if you're in an area where the return interval is less than 100 years for a 45 millimeter or greater hail event, you should be concerned about hail, and you should be thinking about hail. In this particular case, focusing on the blue line there, which is specific for the Fighting Jays project, we had a return interval about 25 years for 45 millimeter hail. And if we take a look at this particular storm, and even just using the greatest observation that we know to be ground observation of around 70 millimeters, this would have been about a 1 in 15,000 year event. So an extremely rare event. And I should also say that this chart is based on historical data, historical radar data and ground observations in the region of, in this case, Fighting Jays. And that's converted into a probability that allows us to calculate a return interval in years. Also look at the diurnal cycle for these systems. So typically your sort of peak frequency in terms of severe hail events is going to be in the mid-afternoon to early evening, and that sort of 4 to 7 p.m. time range when you have the daytime heating that's created a very unstable atmosphere and just allows for a lot of the ingredients that go into these severe thunderstorms to be present. And that's sort of what we saw on the 15th with that storm that came through about 5:30 in the evening. It sort of fit into that peak time. The storm on the morning of the 16th was much more rare. But I also want to note that while it was a rarer event, the probability is not zero. And so that sort of leans into the fact and the importance of nighttime stow and being in hail stow when possible, because the probability at any time of the day is not zero. And in this case, you know, we saw a severe event. I think with that, that's a great transition back to John. So I'm going to toss it back to John Provatelli.
Great. Thank you so much, Dennis. Really appreciate that. Great job. All right. So what happened? So at Fighting Jays, I think it was evident there was a tremendous amount of damage. We actually didn't interview the owner or the operator of Fighting Jays, but many of us saw on the national news that there was a tremendous amount of damage on that project. I think there was if I recall correctly, there was a helicopter that flew over the project shortly after the storm that showed a tremendous number of broken modules. It was really very sad to see because so much work, particularly because so much work had been put into that project. So, but at Old 300, excuse me, and Cutlass 1 and Cutlass 2, we did interview those operators, and we confirmed that those projects indeed went into stow, went into hail stow, where the modules were turned to the most extreme angle. We actually don't know which direction the modules were turned relative to the wind. Wind direction is very hard it's basically impossible to predict using current technology when hail is actually falling. Oftentimes, it's a very chaotic situation when hail starts to fall and the wind direction is not consistent with the prevailing storm direction. But in these three cases, there was no damage for trackers and modules that went into hail stow. And at Old 300, interestingly, there was one known tracker motor fault going on. It was known before the project. And so there was one table of modules consisting of about 40 modules that did not go into hail stow because of that known motor fault. And those modules were damaged by hail. So that was actually a very good proof point that hail stow worked to defend the rest of the Old 300 project against hail. At Old 300, there was also a medium voltage transformer that was damaged slightly because an oil gauge was broken. It was repaired. And yeah, so this is great news. You know, we've been talking about the benefit of hail stow and encouraging people to institute hail monitoring and stow for a few years now. And we've heard, you know, confidentially that it's working from owners and operators. But this is the first case where we can share this information, this great news publicly, that hail monitoring and stow is effective to reduce, and in this case, really avoid damage to projects. I don't want to say that hail monitoring and stow will always result in no damage. There's always a risk of damage, but it certainly reduces the risk of damage significantly. And before I end my section, I just wanted to go back quickly and note that, you know, this chart that Dennis shows of the return intervals, it shows that these storms are, you know, very rare. However, you know, forecasting, it's not a perfect science, right? And so as Dennis mentioned, we recommend that anyone who is in an area with a return interval for hailstorms that have 45 millimeter or greater hail protected return interval of less than 100 years, they take measures to institute hail monitoring and stow, because you can have very damaging hailstorms in those areas. Even if it seems like they're rare, they could still happen. And also, I also want to really emphasize the importance of hail stow and also hail stow during construction. Cutlass 2 was partially under construction, and from what we can tell, the EPC contractor did a good job in putting the trackers into hail stow during construction, even though they were not capable of being put into hail stow remotely because a portion of the project was not energized. And this is a very simple thing to do for construction people to do. They can simply just unlock the tracker mechanism put the tables into a hail stow manually just by hand, and then lock those trackers in place in hail stow. Okay, so to wrap up, let me just drive home these points. Hail stow successfully prevented module damage at these projects that were exposed to really greater than 1 in 500-year hailstorms. At Old 300 and Collis 1 and 2, there was no damage for modules that went into hail stow. The only damage was limited to a table that had a known motor fault that had not been repaired, so it could not go into hail stow. So that's an important point too. Repair those motors as quickly as possible, so you don't have a situation where you can't put the trackers into hail stow. So even in severe hail conditions, hail stow positioning can significantly reduce damage, as I mentioned. The proper implementation of these protocols in collaboration with the operators under contract is really critical. And so is reliable weather forecasting. So having at least a regional alert, but ideally both a regional alert and a project-specific alert, regional alert from the National Weather Service and project-specific alerts from private hail alert companies like DTN, for instance, is a very good one, is really important. And then finally, as I mentioned, really important to put projects into hail stow overnight because whether you're doing automated hail stow or manual, these systems are they're so subject to damage with hail stow. You don't want to take a chance that the automated hail stow may not work, and or if it's manual hail stow, that there's no one to actually put it into hail stow overnight. You really want to have these systems in hail stow overnight. And finally, let me just put a plug in for automated hail stow. So we see a lot of projects out there that are starting to use hail monitoring and stow, and that's great. There's still a lot of work to be done. In many cases, annual hail stow procedures can be implemented right away, as you would expect. But it really requires that the operators remain extremely vigilant and put the trackers into hail stow very quickly when they receive an alert. And there's human error involved in that. So we really recommend that owners and operators implement automated hail stow that will automatically put the trackers into a hail stow position based on a regional and or project specific alert, and then use manual hail stow as a backup. All right. We do have a best practices document that describes what I'm talking about. It's available for free from our website. So we actually co-authored this with our largest customer, Wells Fargo. It goes over all the stuff that I'm talking about and more to help people adopt best practices with regard to hail monitoring and stuff. So I want to thank you very much. And my management has asked me to say we are protecting critical energy assets to ensure a worthwhile future. Please join us. Thank you very much. I think I'm getting over to Sumant. Is that right?
Yeah. Thank you, John. Thank you for you and Dennis for walking us through this independent study of the Fort Bend, Texas hailstorms. So it clearly showed the challenges of managing hailstorms, and further, these array systems stowed and prevented module losses during these severe and unusual storms. Now, I also want to highlight that these systems were stored manually by operators using SCADA based on their weather monitoring observations and decision plans. Now, I want to talk to you about Array's hail alert response that's built on Array's SmarTrack control system. This is Array's automated hail response system. It takes the guesswork away during a live event. Again, as John pointed out, there are many things that could happen, including human-driven factors. So an automated hail response is an important part of the toolkit. First, let's walk through SmarTrack. The SmarTrack system is a supervisory layer built on top of Array's hardware. It offers the functions catered to the challenging demands of today's modern solar trackers that go beyond just moving modules with the sun. So it offers things such as performance improvement, things like terrain adaptive backtracking, and diffuse weather response. Also, ease of design and operation, such as visual command and control via the SmarTrack controller interface. And finally, severe weather risk management, such as the hail alert response and the automated snow response. Now, the rest of my presentation, I'll focus more on the hail alert response. So this is a very detailed slide, so let's take this piecewise. Before we dive into the details of hail alert response, let's talk about storm warning systems. Let me direct your attention to the left bottom side of the. So we have weather service providers via APIs that allows us to track storms and react based on parameters. In this graphic, the blue is the center of the site, and the red circle is a defined perimeter around the site. So the proximity, direction, and speed of the storms is tracked by the storm polygons that you see. And again, you can have many of these polygons within a storm system. Now, as you look at the polygons, the rear side of the polygon, it shows the current location of the storm, and the front short end of the polygon is the predicted position of the storm in 30 minutes. Now, as the moving storm intersects the circle, alerts and actions can be triggered for hail stow. Also, the radius of the circle can be altered to change the time to initiate the stow commands. And now let's talk about the hail alert response implementation. As you can see on the top right side, the SmarTrack data platform is implemented on the Microsoft Azure, so a high reliability platform. So the SmarTrack data platform, it communicates with the weather service provider. We're illustrating DTN in this case, but you can have a variety of other service providers. So it analyzes the impending storms and verifies if the storm polygon is in proximity of the site perimeter, as I talked before. And then it retrieves the storm parameters against established site thresholds. And finally, raises the storm alert and communicates with the SmarTrack controllers using the Weather Alert API. And it also logs the storm alerts and the parameters. So the storm alert, once received by the SmarTrack controller at the site perimeter, as shown in the bottom right, then pushes that command to the 6X controllers and the individual motor controllers, which then stows the site to a hail stow that's predetermined or programmed into the hail automated response system. Now, another aspect I want to bring your attention to is the parameters that's typically specified by the weather service providers, like DTN in this case. So you get parameters such as location of the storm, the direction of the storm, the speed of the storm, the probability of hail, and the maximum size of hail expected. Now, you can use those inputs and verify it against preset thresholds within the hail automated response, such as the probability of hail, as well as the maximum size of hail that you want the system to react to. So, and then beyond that, this slide is talking about key attributes of the hail alert response. Again, in this case, we talked about DTN. We know that both DTN and the array systems are based on cloud platforms that provide 2 nines, or actually even 3 nines of uptime guarantee. And then we essentially can program the parameters into the automated hail response, either max tilt or and so we talked about things like the probability of hail as well as the maximum size of hail to react to. But beyond that, we can also program in which direction you want the trackers to stow. And mind you, that DuraTrack can handle high tilt stow in either direction and be prepared for hail and wind resilience. So those thresholds can be changed to be more or less conservative, and we recommend recalibrating those thresholds after every storm with actual site event data. Finally, this defensive stow is released 30 minutes after an all clear alert is received from the weather service provider. Now that we understand hail alert response and its capabilities, let's take a step back to the Fort Bend events and articulate some key learnings. Based on what we observed, we can state the following priorities for successful hail stow. Number one, did the tracker reliably stow? As VDE walked us through, the DuraTrack system stowed reliably for hail. Number two, did the tracker stow away from the wind? In this case, we do not know what direction the site owners chose to stow, but within the hail alert response, we allow user configurability to stow in either direction. You can stow to the nearest extreme direction that the wind is coming from, or you can stow away from the wind. But the key takeaway is that arrays trackers can be stored at the max tilt angle at either direction and can survive both wind and hail. And then number three, what angle did the tracker stow? While the prevailing discussion is how high can a tracker stow, we have seen from this example that a 52-degree stow withstood hail of 75 plus millimeters on DuraTrack. That said, we do recognize that steeper angles do provide more resilience against larger hail. And we have a 77-degree tracker that can handle that larger hail for your projects. Finally, these priorities ring true against the backdrop, given findings from KWH Analytics that industry modeling assumptions can underestimate risk of loss by 300+%. Therefore, you need a tracker that can perform against these priorities as we have demonstrated today. Lastly, I want to touch on something that is uniquely Array. Most of you are familiar with tracker operation, where the tracker stows based on wind speeds measured from wind sensors or anemometers. Array is uniquely different in two ways. It uses a hybrid stow on DuraTrack since its inception. The active stow, as you're all familiar with, is sensor, alert, or operator triggered. That's the vast majority. But Array's DuraTrack also has the passive stow that is mechanically triggered by wind pressure the tracker experiences. Another key differentiator on the DuraTrack from the get-go is it has been designed to stow at the highest tilt angles. So this is better explained by a response you're all familiar with. I call it fight or flight. Most other trackers, when faced with high winds, right, take flight to a lower safety stow. However, the DuraTrack, in contrast, was designed to stow at the highest tilt angle for both, forward and backward wind, and it can handle that high tilt at either direction, and that's what makes it very unique. And again, to touch on what I just discussed, it's illustrated here. So Array's trackers are agnostic to if it's a wind or a hail event occurring simultaneously or one follows the other. When other trackers exist, So how that conflict is managed with other trackers, it's an important consideration. For us, our patented design solves that conundrum. Now, let me pass the mic back to Kathy, who will take us deeper through the additional value of passive stow.
So I'm going to talk about a little more in-depth detail about Array's passive stow capability. Pretty much what we talked about related to hail is our active stow capability, but our passive stow, as Sumant said, is quite unique. And one of the things that the Array engineering team did last year is they developed a new methodology and a new software algorithm to model wind stow and its energy loss impacts. The key thing that the Array team brought to the table in doing that was using very high wind resolution data. And so the method that Array developed takes any resolution of data. It could be anything from 1 measurement per second to 1 measurement per minute. The software algorithm averages to a 5-minute average interval, and that's what's input into the model to calculate using a high resolution set of data. Most analysis methods today, and there are quite a few out there, quite a few companies who do wind stow loss analysis, most of them all use hourly wind data, which is significantly lower resolution. And so in addition to using the high resolution wind data, the Array engineering team developed a variety of capabilities to model different wind stow parameters, particularly active wind stow parameters. So being able to input everything from the wind stow threshold speed to how long the modules would stay in the stow position to at what point do the modules go back out of stow. So of quite a wide variety of parameters were input into the model and built into the model to simulate different active wind stow capabilities. So the output of the software algorithm that Array developed creates all the different tracker angles at every moment of time over the course of a year at a given wind site. That data then is input directly into Plant Predict, and it's Plant Predict software that calculates the energy production. And so after we did this work, we got a bunch of sets of data and looked at a bunch of different types of active stow parameters. We went to DNV. We asked DNV to look at our methodology, look at the process that we were using, look at our algorithm, look at the data sets, and look at the results that we were getting, and provide an assessment of what they thought of the work that we did. On the right, you'll see the cover for a very detailed 14-page technical paper that DNV created as part of their analysis of our wind stow study. So if you go to the next slide. Nope. Okay, great. So basically, I'm just going to talk about the high-level DNV findings for the work that was done. If going through the 14 pages of technical detail, this is the summary of what DNV found in the work that we did. Basically, the tracker angle profiles that we created are reasonable. The methods that we use to process the data and for using in the different stow models are consistent with industry standards. The most important thing from my perspective is that DNV found that the use of 5-minute time steps improves the accuracy of the wind stow loss calculations. Now, again, that's in comparison to pretty much everybody in the industry today is using hourly wind data. DNV also noted that the choice of modeling software and project assumptions are reasonable. And the key from the work that DNV did in assessing our new method of calculating energy losses was of the different data sets that they reviewed. The annual energy losses are shown very clearly. For passive stow, the energy losses ranged from 0 to 0.1%, and this is in terms of annual energy output loss per year. But with the different active stow parameters that were modeled, the annual energy production losses ranged anywhere from 0.7% all the way to 4.3% for active wind stow. So clearly, active wind stow, depending on the wind conditions, I'll say for the particular region of the site, it could be very significant. And for those interested in obtaining the white paper, you can go to the Array website and request access to it. Next slide. Okay, so we covered a lot in this webinar. The key takeaways, I'll just wrap up very quickly here. So we saw that Array's DuraTrack system has been proven to be highly effective in protecting modules during 2 major hailstorm events that occurred last year in a 12-hour period in Texas. We also showed that the reliability of the system protect from severe hail, along with its unique passive wind stow technology, makes DuraTrack an optimal solution for extreme weather events. Array's passive wind stow benefit, depending on the region of the site, if it's a high wind region, the energy savings per year accumulated over the life of a site can actually ultimately pay for the system itself. And lastly, with the extreme weather events increasing in severity and frequency, with data that we've all seen in the industry, Array is introducing a high angle tracker that you may have heard about to bring even greater protection to modules in very severe hail regions. So with that, I will pass it over to George and we will answer questions.
Great. Thank you to all of our presenters. That was a fantastic presentation. Hopefully that answered a lot of your questions, but we have had some additional questions come up in the Q&A. So thank you to everybody for submitting your questions. We will start to get to them. First question, we were just discussing passive wind stow. So will passive wind stow move the panels if in hail stow? And will this change throughout the field as the edges typically experience the stronger wind uplift pressures? Kathy, do you want to take that one?
Actually, I'm going to defer to Samanth for that. He's been studying that aspect of our system.
Yes. So the hail stow basically puts the entire site into the predetermined hail stow position. So be it the exterior or the interior row. So that way we're protecting the whole site.
Great.
Was there anything else that I missed, George?
Oh, I think that answers the question. Yeah, it will be at full stow, and the panels will typically tilt to the direction of the leading edge, and so as that is the default mechanism of Array's passive wind stow is to go to full tilt, especially in the exterior rows. So it will not move that from that position in the chance of a hailstorm. Next question. Are there warnings that only apply to hailstorms, or are such warnings always combined with high winds? For example, a severe thunderstorm warning.
John, perhaps you're better positioned to take that question.
Yeah. Actually, so the answer is yes, but it's nuanced. So I'm going to hand it over to Dennis, our meteorologist, to elaborate on that.
Yeah, absolutely. So when a severe thunderstorm warning is handed down from the National Weather Service, for example, the definition specifically specifies that polygon is at risk of 1 inch or greater hail or 58+ mile-an-hour winds. So in a lot of cases, you're dealing with severe thunderstorms that are producing both of those things, right? But the warning itself the statement is or. So you can have situations where you have hail that's exceeding that threshold with a particular storm and not wind, and vice versa.
Yeah, we really recommend to, as our friends at KWH Analytics, the insurance company, always talk about, to stow early and stow often. I mean, there is such a huge risk of loss here, and the sacrifice of energy production is almost always minuscule because of overcast skies during storm conditions. So there's really no reason not to stow early and stow often.
Great, thank you. Next question is a great question, especially for site owners. Given the apparent efficacy of stowing, are there any insurers who provide reduced rates or otherwise better terms for those projects that stow or are stowable?
Yes, can I take this one?
I can take that question.
Oh, go ahead.
As well. And John, please feel free to add your perspective as well. So Array has been engaged with a number of different insurance and related companies in the utility solar industry. We do know that many of the insurers are seriously looking at ways that they can assess tracker capabilities and performance to determine where reduced rates may apply. And so that is actively happening in the industry. We're keeping up with it as changes are occurring today and in the near future. John, you probably have a broader perspective on the insurance industry and their perspective on hail.
Yeah. I'll just add to what you said there. So, yeah, the good news is that insurance companies are starting to provide discounts for operators who demonstrate hail monitoring and stow, specifically through testing. So a really good example is a company that I mentioned before called KWH Analytics. It's an insurance company. They're really at the leading edge of all this. They cater specifically to the solar power industry, and so they've been very involved in spreading the word about the value of hail monitoring and stow. And recently, they announced that they provided a 72% reduction in insurance rates for a company that was able to prove to them that they had reliable hail monitoring and automated stow. And in fact, in I think a couple weeks, VDE is going to do a joint press release with KWH Analytics to promote it sounds simple, but it's very powerful, a form that owners operators can fill out and return to us and or KWH Analytics to demonstrate that their hail monitoring and stow protocols are in place and working. This is, prior to funding the projects during the commissioning time, and also on an ongoing basis during the operational period. We recommend it testing at least once a month. So yeah, so it's happening. The discounts are happening.
Great. Next question. We heard that roughly 10 modules at Old 300 were damaged by windblown objects. Was this mentioned by the asset owner when you contacted them?
Yeah, that's right. Yeah, that's correct. Yeah, and I don't know if I don't think I actually mentioned that. So apologies, but yeah, that is correct. There were about 10 modules that were damaged by windblown objects. That does happen from time to time.
Great. Next question is there insight to what the stow angle was at the different sites? Was it the same degree or different degrees?
52 degrees.
Question for my Array colleagues. Are there any plans to integrate other weather services besides DTN?
Yeah, I can take that one. I know our team is actively looking into other weather service providers, and yeah, if we can reach out, if you have a specific provider in mind, we can work with you to get them on board.
Great.
And additionally, just a note, We are also looking at weather providers outside of the US.
Our next question is there a point where a decision has to be made when the hail is risky enough to damage and the wind is windy enough to cause damage? And how would this be sorted?
So again, as I mentioned, with the Array's passive stow, the DuraTrack is designed to handle either hail or wind at its highest max tilt position. So the best solution is to immediately put the tracker at its highest max tilt solution, either facing into or away from the wind, and it can handle all those scenarios in either of those positions.
Yeah, and I'll just chime in and in addition to what Sumant said, and say that from what we've seen through forensic analyses, if for some reason you have to make a choice between hail stow and wind stow, choose hail stow. Hail is much more damaging than wind in all the cases that we've seen. So far we've really, aside from tornadoes, which where you really can't prevent damage. Those things are like lawnmowers just going right through the site. But for wind damage, typically we only see damage around the edges of the array and oftentimes just one corner of the array. And that damage, is oftentimes to modules, but oftentimes it's just to the brackets that connect the modules to the torque tubes, right? So it's nothing compared to having a hailstorm come through and just annihilate 50% or more of your modules.
And yeah, just to close out that discussion, our hail automated response system is designed to prioritize hail stow above and beyond any other stow.
We have a great question. Can the stow's standard operating procedures move through the flat position when moving from a straight line storm stow to a hail stow?
With array trackers, yes, you can do that. And it's because of the unique passive stow. And there are videos on our website about how the passive stow works. You can go check it out, but it really quickly moves the tracker into the passive stow.
And Sumant, another question for you. You did briefly mention this, but are there plans to increase stow angle of array trackers to something greater than 52 degrees?
Yes, we recently announced a 77 degree stowable hail tracker that should be available for quote here soon. So yeah, just reach out to us specifically if you have sites that have high hail risk with large hail sizes.
Great. Next question, maybe for Dennis. How will potential staff cuts at NWS affect early hail warning and/or reliable weather forecasting?
Right, it's a good question, and I think it remains to be seen. However, the National Weather Service will continue to operate a radar network that will continue to, use the staffing that they have to issue warnings and continue to keep the public's interested as best as they can. So I don't think any of the services are going to stop. I haven't seen anything that indicates that. So the warnings will continue to come. The radar information will continue to come, and
Yeah, and I can chime in a little bit more about that. So, we recently got that question from one of our biggest customers, Wells Fargo, who's very concerned about not having monitoring capabilities available because of staff cuts at NWH and NOAA. And it is a risk, right? So what we've talked to them about is, if there are weather stations, radar stations that are not being maintained because of staff cuts, increase the area of monitoring into a wider region that are covered by radar systems that are maintained, or in the case of like very large projects where there is no radar anymore, worst case scenario, buy a radar station. They are expensive. They're $1 to $2 million, but they are available from Vaisala, and they can be put at the project site and even shared among multiple projects in an area, and you'll get the radar coverage you need.
Okay, great. With that, we are out of time. I would like to thank our 4 speakers for joining us and providing this very insightful discussion of defending your solar assets, lessons in extreme weather preparedness and mitigation. And thank you to all of you who took the time out of your day to join us for this webinar. You will receive a recording of this webinar and slides as well. So if you have any other questions, you do see the contact information for our speakers. Please do feel free to reach out. And once again, thank you all for your time. Hope you enjoyed the webinar.